Welcome to homework.
We have to carry out each calculation and pay special attention to the significant figures when we're rounding. So for this first one, our final unit is going to be grams over centimeter cubed. It's not clear by the way I've written it, but here you have centimeters, and we're going to be cubing this value. So when you're considering significant figures and you're doing multiplication and division, you always want to go with the fewest number of significant figures. So here we have 3, here we have 3, here we have 5. This term, 4/3, this you can consider a constant and therefore not worry about it when you're actually doing your calculations. So let's start with the first one. We're going to have 4.32 times 10 to the 7th on the top. And on the bottom, we're going to have 1.95 times 10 to the 2 squared, cubed. And then that's going to be multiplied by 4/3 times 3.1416. And the 1.95 times 10 to the 2 cubed, that is 7414875. Now, in the middle here, the key thing to remember is don't round in the middle of your problem. So whatever calculation you are doing, keep all of the calculator nonsense while you are carrying out your calculation. You only round at the end. So let's continue. We're going to have 4.32 times 10 to the 7th on the top, and we're going to multiply our previous answer by 3.1416, and then multiply that by 4/3. So then our bottom number becomes 3105942.8.40. Again, we are not rounding. So what we're going to do is we're going to finish by taking 4.32 times 10 to the 7th, divide it by our previous answer. And at the very end, we're going to get 1.390882 ... Here is where we round. We want to go to 3 significant figures. So this is going to be 1.39 grams per centimeter cubed. Now let's take a look at B. So here, again, let's count up our significant figures. We have 3, and it's not clear if this is a constant or an actual value. So I am going to assume it is a constant. Otherwise, we would have to go to one significant figure. So I'm just going to assume that this is a constant. So we're going to have 1.84 times 10 to the 2. Next, we're going to have 44.7, that value squared. So 1998.09, all of that divided by 2. So let's finish up our numerator. And this is going to be 367,648.56. And then we are going to divide that by 2. So our final answer is going to be 183824.28. We have to go to 3 significant figures. So there's a couple ways we can do that. We can basically move the decimal point inward so that we only have 3 numbers like our in scientific notation. So that's going to be 1, 2, 3, 4, 5. So that's going to be 1.84 times 10 to the 5th, or you can just say 184 and then put 1, 2, 3 zeros after it. Now, if you wanted to go to just one significant figure, for example, this value would round up to 200 and then 3 extra zeros. Or you can say 2.00 times 10 to the 5th, but then those 2 extra zeros, they would actually be considered sig figs. So instead, you would just say 2 times 10 to the 5th. Now let's take a look at C. So C is a little bit different. We have various sig figs. So again, we have 3, 2, 3, and 3. So our final answer is going to have 2 significant figures. So let's work with the numerator first. 1.07 times 10 to the minus 4th, that value squared, multiplied by 3.8 times 10 to the minus 3. So in our numerator, we're going to have 4.35062 times 10 to the negative 11. On the bottom, we're going to have 1.48 times 10 to the minus 2. That value is going to be cubed, and we're going to multiply it by 8.35 times 10 to the minus 5th. So on the bottom, we're going to have 2.7068962 times 10 to the minus 10th. So let's complete our problem by using all of the digits in the numerator and then dividing by our previous answer for our denominator. And the concentration is going to be 0.1607235, blah, blah, blah. We have to go to 2 significant figures, so that's going to be 0.16, and the units are molarity. Now, a key thing to note, this 0, this first one, is not a significant figure. You can tell because if you were to put this in scientific notation, it would be 1.6 times 10 to the minus 1. Notice that the 0 goes away. If the 0 goes away when you put it into scientific notation and it is not a trailing 0, then that 0 is not significant.